Hello everyone, we are now on the chapter that talks about organizing data. Now previously we said that in order to perform a statistical study, we first need to collect data, right? We collect data, and where do we collect the data from? From samples, because we cannot work with the entire population because of its enormous size. We work with a sample drawn from the population, which is representative of the population. And once we get our sample, we create our sample, perhaps using all the different techniques. We will then go and collect data from the sample. All right. Now, the data we collect is going to come to us in a very random fashion. It's going to be raw data. It's going to be all over the place. So in order to make some sense out of the data, in order to get our arms around the data, what we have to do is we have to organize the data. So we are going to learn the ways of organizing data. Now, the way we organize our data depends on what kind of data we are dealing with. Now, previously, again, we said that data would be of two kinds. One is the qualitative data, data that's given to us in the form of names, nominal data or categorical data, qualitative data, and then there is quantitative data, which is numerical data, quantitative data. And quantitative data itself can be divided into two, one being discrete data, that's countable data or countable values, all right, numbers that come to us in the form of values which are countable. And the other one is continuous data, which is measurable data. All right. So discrete is countable and numbers that are countable, and continuous is measurable. So that's how we can uh, we can uh, differentiate between discrete and continuous data, right? So in this section, we will essentially talk about organizing qualitative data, and then we'll go on to organizing quantitative data. So like I said before, we will learn organizing data in two parts. The first one being qualitative data, working with qualitative data. There are different ways of organizing, representing qualitative data, and also graphically presenting qualitative data. And then we'll go on to quantitative or numerical data, and we'll learn how we handle uh, data that comes to us in the form of numbers. There are three parts to organizing qualitative data. Once we get the results of our data, we have to tabulate them, and we tabulate them in what we call frequency tables. Frequency tables essentially tell us how frequently a particular response occurs. All right, so frequency tables will tell us or will display how many times or how many times or how frequently a particular response occurs. All right, a particular response occurred. And the other two, these two are graphical representations of the data, of the qualitative data. One is through pie charts and the other one is through bar graphs. So let's go on to finding out how we can organize qualitative data in frequency tables. Now here are the steps to construct a frequency table for qualitative data. As you can tell, any table is going to have rows and columns, right? Now, for qualitative data, the columns in the table are going to be the following. The first column will have the names or categories of different items that we are studying, or names or categories of responses, really. All right, so we'll go into more detail. We'll work through an example on that, but just know for now that the first column is going to be a list of names of different responses that we have received. The second one is the column for tallying. So we will learn how to do the tallying, but essentially there at that point we will be counting how many times a particular response has occurred. Now the third column is to count the tallies and determine the frequency. That means the frequency of occurrence. We have to just count the tallies and then just write the numbers. All right. And then the last one, and it can have more than 4 columns, but for now, the last one will be called a relative frequency. That's a calculated column from the frequency from the previous column. Again, we will go through the process through an example, but the relative frequency actually tells us the proportion of occurrence of a particular response, right? So let's read what the steps here before we go on to the next slide. It says in step 1, we list the distinct values of the observations in the data set in the first column of the table, and that's what I said would be the names of the responses we received, the distinct values of the observations. Step 2, for each observation, place a tally mark in the second column, which is the tallying column of the table in the row of the appropriate distinct value. And in step 3, we count the tallies for each distinct value and record the totals in the third column of the table. And we are going to call that column, the third column, frequency column. And then we will take that on to calculating relative frequency, which will be the fourth column in our table. Now here is an example we are going to use to construct a frequency table. As you can see over here, this data set before us has a bunch of names of political parties, right? Democratic, Republican, and the other one is other. So that means a study was done on a sample of 40 people, asking them what is their political affiliation. And these were the responses received. So 40 people were asked, what is your political affiliation? And they responded Democratic, Republican, Republican, Republican. Another person responded Democratic, and then a few Republicans, and then other. So we have the data randomly presented here. All right, from here it's not possible to determine just by looking at this raw data. It's not possible to determine how many said Democratic, whether more said Republican than Democrats, and how many were other, and so on. So we have to tabulate this and put it in a frequency table, and that's what we are going to do in the next slide. Now we are going to get on with creating our frequency table with the data on political affiliation that was presented to us in the previous slide for 40 people in a sample study. So I've brought over the raw data over here because we need it in order to create the table. So in the first column, as you can see, because the responses were related to political affiliation, that means the party to which they are associated, we name the first column as party or political affiliation, whatever you want to name it, and then the names of the, or rather the responses that were given. So the responses came to us in the form of Democratic, Republican, and other. These are the 3 unique responses in this data set. So we just list them. The first one is Democratic, the second one is Republican, the third one is other. All right. And then in the next column, in the second column, which we have labeled as tally, we are actually doing the counting. So we are going to go one response at a time and count them and tally them in the second column. So let me take out my pen here. So the first response was Democratic. So I'm going to put a straight line in the tally column and cross out the Democratic just to make sure I do not double count it or I don't get confused somewhere in the middle thinking, where did I count it or did I not count it? So it's better to cross it out just as a good work habit. The next one is Republican. So I'm going to cross that out and put a tally, a straight line mark on next to the Republican in the row for the Republican under the column for tally. The third response was also Republican. Let's cross that out and put a tally over here for Republican. Then we have Republican again, put a tally for Republican. What's next? Next one is Democratic. So cross that out and put a straight line for Democratic. Then we have Republican again. We put a tally. And then a Republican again. Now this is the fifth one. So for the fifth tally, we put a mark across, diagonally across the four tallies we got previously. Just put across, because that way we bundle our tallies. All right, because that way it's easier to count in fives. So when we do the counting in for the third column, for the frequency column, we can just go 5, 10, 15 and so on, rather than if we have a bunch of these lines, it's very easy to make mistake while counting. That's why we group them together in fives, in bundles of 5. All right. So what do we have here? Did we cross out? I'm already confused now. Did we cross out the Republican that we marked across? 1, 2, 3, 4. No, we didn't. So I need to cross that out. All right. So again, it's very easy to get confused. All right. Don't get distracted when uh, doing the tallying, and make sure that you are counting all the responses and also not leaving out, not missing out anything. All right, the next one is again Republican. So we mark the Republican with a tally. Then we have an other. That's the first other we got. So put a tally next to other. Then again Republican. So we got a Republican, another tally for Republican. Then we got Democratic. Then we got another Democratic, so another straight line. And then we have a Republican again, so that's the still a straight line. And then we have a Democrat, but this is the fifth Democrat, so we put a line across the first 4 tallies. All right, so now that's bundled into 5. Republican next. Now this Republican is also the fifth one in the second set, so we put a tally across. All right, so then we have this Republican needs to go. All right, then we have a Democratic, and then other, then Republican, then Democratic, then Republican, other, Republican, other, and then Democratic. So I guess you get the idea now. All right, how we do the tallying. You have to go one by one through the data, put a tally next to its name in the table, and if for every fifth uh, count, you have to put a line across the 4 to bundle them into 5s. All right. And then once we are done with the tallying, we have to count the tallies in and write it as a number in the frequency table. So for Democratic, we had 5, 10, plus 3, 13. For Republicans, we had 5, 10, 15, 15 plus 3, 18. And then for other, we had 5 plus 4, 9. And then at the end, you have to count the different frequencies and get a total for the frequencies, and that should match the sample size. Now this N, it's denoted by the letter N. That's the sample size or the total frequency. All right, size or total frequency. And the total frequency should always be equal to the sample size. If it isn't, then you have made a mistake in counting. Must have made a mistake in counting. If it does not equal the sample size, we have to go back and recount. Maybe we missed something, or maybe we double counted a response. It could be anything. All right, but the sum of the individual frequencies must add up to the sample size. In this case, 40. 13 plus 18 plus 9 is 40. Right? Now we'll go into understanding what relative frequency distribution is. Now, earlier I told you that there will be a fourth column in our table for qualitative data, which is going to be named relative frequency. And what relative frequency does is it gives a proportion of distribution of the frequencies. So what proportion, which can be translated into percentages later on, what proportions of the respondents said they were Democratic? What proportion of the responses were Republicans? What proportion were other or was other? All right. So the relative frequency is a calculated value. It's calculated from a very easy formula, F over N. F standing for frequency and N is the total number of observations or your sample size. So let's go through this first, and then we will go through an exercise of calculating the relative frequencies. So relative frequency distribution of qualitative data. Relative frequency distribution of qualitative data is a listing of the distinct values and their relative frequencies. So relative frequency is calculated by taking each frequency number and dividing it by the total number of observations n. Therefore, it's going to have the formula F over n. That means it tells us out of the total number of observations, how many or what proportion said yes. So you're seeing how many said Democratic in our example. How many were Democratic out of a total of 40 respondents? F over N. And once we calculate we should come up with a ratio number between 0 and 1. Okay, so to construct a relative frequency distribution of qualitative data, obtain a frequency distribution of the data, we have to know the frequency. So we have to go through the process of tallying and then counting and getting our frequency number, frequency value, and then once we have the frequency value, we divide each frequency by the total number of observations, which is going to be n. All right. So here we have our frequency table, but we have removed the column for the tallying. However, if you are starting off with raw data, then you will need the column for tallying. Otherwise, it's not possible. It's very easy to get confused if you are just counting from the table. All right, it's always good practice to have a column for the tally. But here we have the first column naming all the different unique responses, Democratic, Republican, and other. And then the second column now, this time, is the frequency or F, and we had 13 respondents who said Democratic, 18 said Republican, and 9 said other. And then in the third column here is relative frequency, and that's a calculated column. So to get the values for this column, we just have to take our frequency value 13 divided by 40, and we come up with a value of 0.325. So how did we get this number here? Just take your 13 and divide it by 40. It's F, let's use a different color. It's F over N. Shouldn't be writing it here really, just a second. It's here. All right, it's here, F over N. So 13 divided by 40 gives us 0.325. 18 divided by 40 is 0.450. 9 divided by 40 is 0.225. All right, so that's how we get the relative frequency numbers, and note that these numbers will be a ratio between 0 and 1. All right, it cannot be less than 0, it cannot be a negative number, that is, or it cannot be greater than 1. And when you sum up the relative frequency values, they should add up to a 1 or very close to 1. If there are any rounding, if you've rounded up your values, then you will not get an exact value of 1 when you sum it up. It will be close to 1. It should be very close to 1. And always round up your values to the third decimal. All right, do not round it up to 2 decimals. Round it up to the third decimal in statistics, unless the question says otherwise. Just keep your decimals up to 3 places. All right, so that's how we calculate our relative frequencies. And then this column, the last column, is called the cumulative frequency, and we get the values for those. We take the first value, so the first value will be whatever is the relative frequency value for the first row, but for the second value it's 0.325. So this plus this gives us 0.775, and then 0.775, so this 0.775 plus 0.225 should give us a 1. All right, so if take 0.775, add 0.225, it should give us a 1. So that's how we get the cumulative frequency values. All right. Now that we have learned how to tabulate our qualitative data, we will now go into graphically representing this data. All right. So pie charts is a form of graphic representation of data. Graphic representation, and there'll be another one called bar graphs. All right, but the first one is pie charts, and as you can tell, pie charts are round, so our graph is also going to be circular in shape. Okay, so pie chart is a disk divided into wedge-shaped pieces proportional to the relative frequencies of the qualitative data. So we will have a circle, and then we will divide this circle into sections, but not equal sections. They may not be equal sections. They may be unequal wedges as pieces of pies, right? But they will be proportional to whatever relative frequency value we found from our calculations, from our frequency table. All right, so we will have to draw our pie graph with slices in it showing slices or wedges, which will be equivalent to the relative frequency of the responses. So to construct a pie chart, obtain a relative frequency distribution of the data. So before we go into graphical representation, we do need our frequency table. So if somebody gives us the raw data set, which is all over the place, we have to organize it in the form of a frequency table first, tally the data, that is count the responses, and put them neatly on a table, and then get the frequencies, and from the frequencies we calculate the relative frequencies. Remember, the relative frequency is a calculated value using the formula F over N, frequency over the total number of frequencies, also N, also called sample size. So we need that step done first. And then in step 2, we divide a circle. Now a circle has a total angle of 360 degrees. So we are going to use that information that a circle has 360 degree angle into wedge-shaped pieces proportional to the relative frequencies. And again, we will go through an exercise to demonstrate that. And then finally, we will label the slices with the distinct values and relative frequencies. In other words, after we are done creating or dividing our pie into pieces, we have to label them. That means this one we have to say represents Republicans, then we have to say this one perhaps the Democrats, this one the others, and so on. All right, and we have to also put the proportions next to it, because as we can see here that Republicans responded higher than any other responses, any other affiliation. Republicans occur more frequently. However, how frequently, all right, we have to indicate that proportion value as well in our diagram to make it complete. So here we are going to go about constructing a pie chart based on the relative frequency values we found for our political affiliation example, right? So the first step is to obtain a relative frequency free distribution of the data, which we already did in the previous slide. So I just brought it over here so we have it in front of us while creating the pie chart. And then it says in step 2, divide a circle which is 360 degrees. We have to divide the circle into pies. Since we have 3 responses, it will have 3 parts or 3 wedges, right? But how large or how small are the wedges going to be? That's going to be determined from the relative frequency. So the total angle in any circle is 360 degrees. All right. So what we are going to do is we are going to divide 360 degrees based on these proportion values here. So the way you're going to go about it is for Republicans, all right, for Republicans, the proportion, oh, sorry, let's start with Democrats, all right? Since the first row has Democrats in it, let's start with Democrats, all right? So for the Dems, relative frequency value was 0.325. So you're going to take 360 degrees, all right? So what we are going to do is take your 360 degree angle and multiply it by 0.325. In other words, you can also convert 0.325, any proportion value can be converted to percentage by multiplying by 100, correct? So 0.325 is really 32.5%. So what we are doing essentially here is, what is 32.5% of 360 degrees? So multiply 360 by 0.325 and you will get a value. So I'm going to run this through my calculator. 0.325 times 360 is 117 degrees. All right, it's going to be 117 degrees. Then we have the Republicans. Reps are 0.45. So again, 360 times 0.45 or 45% of 360 is going to be, let's do the calculation, 0.45 times 360 is 162 degrees, 162 degrees. And then the others was 0.225, so 22.5% of 360. Multiply 360 by 0.225, so that's going to be 0.225 times 360 is 81 degrees. So now when dividing your circle into these angle values, what I would suggest, or what I find easier to do, is I draw my circle. All right, this is my, let's say, my circle with the center over here. And I'll first start with 162 degrees. Now keep in mind 180 degrees is a straight line. It's a straight line, all right? Straight line. So what I'm going to do is let's just draw a straight line through the center. And 162 degrees, I'll start with 162 degrees. So 162 degrees is a little less than 18 degrees less than 180 degrees. So it'll be a little bit less than 180. So I'm going to make it a little bit less. All right, so this angle is perhaps 162 degrees. Again, it's not accurate, but it should be at least it shouldn't be a straight line. If it's a straight line, it's 180 degrees. All right, so we'll just think this is 112 degrees. So I'm going to now erase this. Just a second. Oops. All right, and I'm going to call this angle. I'm going to give this wedge to the Republicans. This is Republicans, and that's 0.45. So they over here they have given us in percentage form, so we can do the same. So it's going to be 45%. All right, 45%. Now the next one is Dems, right? So Democrats 117 degree angle. We want to give it a pie which has 117 degree angle at the center. Now keep in mind a 90 degree is a right angle, correct? It's like an L-shaped right angle. So right angle, if 90 degree is a right angle, so let's first draw the 90 degree and let's use a different color. So I'm going to, so this was a straight line, then let's say this is a 90 degree angle. Now 117 degrees is 27 degrees more than 90 degrees. So that means it's going to be a little bit wider angle than this 90 degrees. So what I'm going to do is I'm going to make it a little bit more wider angle, little bit more. All right, and erase. Just a second, erase this. All right, so that's going to be my Dems. I'll give the Dems this angle. So that's 22.50. And for the other one, we don't have to measure. It's automatically going to fall for those that responded other, and that was 22. Sorry, I'm sorry. Democrat was 32.5. My mistake. Just a second. This was 32.5. Let's write that 32.5, and other was 22.5. 22.5. All right, so this will be the 81-degree angle, and it's a little bit, we can tell it looks a little bit less than 90 degrees, close to 90 degrees, but a little bit less. All right, so this is how we draw these pie charts or pie graphs manually by hand, by dividing uh, the circle into however many parts we need to, and we use our relative frequency values and multiply the 360 degrees, that is the total angle in any circle, by each of these relative frequency values to get the angle according to which we partition the circle. All right, so that's about pie charts. Now, next we will go into another graphic representation of qualitative data. It's going to be called bar charts. Now, the other graphical representation of qualitative data is bar charts, which is essentially a geometric graph with a horizontal axis and a vertical axis and so on. So let's read through this first. It says a bar chart displays the distinct values of the qualitative data on a horizontal axis and the relative frequencies or percentages of those values on a vertical axis. The relative frequency of each distinct value is represented by a vertical bar whose height is equal to the relative frequency of that value. The bars should be positioned so that they do not touch each other. This is important. So let me just give you a quick idea of what we are talking about based on the language here, and then we will go through an example of constructing a bar chart for our political affiliation problem. So first it says a bar chart has a horizontal axis, right? It says here it has a horizontal axis. So let's draw a horizontal axis. And what do we have on the horizontal axis? The distinct values of the qualitative data. So what were the distinct values that we just worked with? In our example, it had Democrats, right? That was one value. It had Republicans. That was the other value. And then we had something called other, right? So the distinct values are shown on the horizontal, also called the x-axis, right? And then we have what's called a vertical axis or the y-axis. So let's draw the vertical axis, which starts from a right angle. It makes a right angle to the left side of our x-axis. So this is our vertical or the y-axis. And what do we have on the y-axis? We have either the relative frequencies or frequencies. So they could ask you to create a bar chart of relative frequencies or frequency values or percentages. Percentages, all you do is convert your relative frequencies to percentages, all right? But more often they will ask you to create bar charts of relative frequencies. So we are going to divide our y-axis with the relative frequency values and make sure that you fit the largest value of the relative frequency on the y-axis. You have to scale it properly, in other words. All right. So we'll go through the explanation of that in the next slide. Then it says the relative frequency of each distinct value is represented by a vertical bar. So if we can divide our y-axis like this. If we are working with relative frequencies, then 0.1, we could start with 0.10 and then 0.20, 0.30, 0.40, and 0.50. Let me erase the y-axis writing here, and 0.50. All right. And then if the Democrats were represented 0.325, then we have to draw over here. It says a vertical bar whose height is equal to the relative frequency. So if it's 0.325, then your vertical bar is going to go like this, somewhere a little bit more higher than 0.30. So I think I've gone a little too far. So it's let's say 0.325, somewhere here. All right, a little bit above. And then you have to turn and then come down. All right, so this bar, it should have a height which is equal to 0.325. All right, roughly, if that's where 0.325 is. For Republicans, it was 0.45, so this should be 0.40. I don't know why I put 0.45. It should be 0.40. So 0.45 being the relative frequency for Republicans, it would be somewhere in between zero point 0.4 and 0.5. So we have to draw a vertical line, go up all the way to where 0.45 is, maybe here, and then turn around and come down. All right. And then for other, it was 0.225. So somewhere over here, a little above 0.20. So I'm going to do it like this and then go and turn around. All right. So here we have, and let me erase this section here. Now, so here we have three vertical bars, and make sure that in bar charts, these bars don't touch each other. These are distinct bars. You have to have a space between the bars. When we study quantitative data, we will learn something called histograms, which are graphical representations of quantitative data. On over there, these bars are going to touch, they should be touching each other, but not for bar charts. When you're dealing with qualitative data, make sure that there is a gap between the bar graphs for each unique value, for each of the values. All right, and then you have to label it, that this represents the, you always have to label. So give a title to your um, diagram. Uh, say that this is represents the political affiliation. So label the axis. This is political parties, political affiliation, however you may want to put it. And then this represents the y-axis, represents the relative frequencies. Okay, and then put a title, political affiliation of 40 students or 40 people, but you have to put a title. Now, in the exams, the reason I'm emphasizing that is because you know there are points assigned to writing the title, labeling the two axes. So if you do not write or put a title to your graph, or um, describe your x and y axis, you will have points taken off. All right, so that's the reason I'm emphasizing that. So let's go to the next slide and see how they have worked. Should look something similar to this. All right, how the bar chart has been worked out for that. Here are the steps to construct a bar chart, and it should be similar to the steps we followed previously. It says obtain a relative frequency distribution of the data. That's the first step. If we are constructing a bar chart with relative frequency, of course, we have to have the relative frequency values. And then it says in step 2, draw a horizontal line on which to place the bars and a vertical axis to place the relative frequencies. And that's what they've done here. You see, same as what we did in the previous slide, correct? We drew a horizontal line first, and then we divided the horizontal line and label them with the three responses we had in our study: Democratic, Republican, and other. And then a vertical axis to place a relative frequency. So we drew a vertical axis that's extending at right angles from the left side of the x-axis, and then we divided it, scaled it equally into 5 parts. Now, because the highest relative frequency value we had was 0.45, we could stop at 0.5. All right. So we started from 0.0 and we went up to 0.5. We didn't need to go higher than 0.5 because the highest relative frequency we have from our data set was 0.45. All right. So um, what's the next step? Step 3, for each distinct value, construct a vertical bar whose height equals the relative frequency of that value. So Democrats were 0.325, so it goes up a little bit above 0.3, right? See over here, it goes a little bit above 0.3 and then turns around and comes down. So it's a rectangular bar going with a height of 0.32 or corresponding to 0.325 on the y-axis. For Republicans, it was 0.45, and that's why you see its height is somewhere in between 0.4 and 0.5. For other, it was 0.225, so it goes up as high as 0.225 on our vertical line, along our vertical line rather. All right, and then goes around, comes down. So we have 3 distinct bars and none of them are touching each other. There's a gap between each bar, equally spaced gap. All right, so keep in mind, again, for bar charts, you have to have a space between the bars. And over here, look, they have put in a title. They called it political party affiliations, and they have also labeled the x-axis calling that party and the y-axis calling that relative frequency. All right, so label the bars and axis. So that completes your bar charts for qualitative data. Now we are going to go into uh, the organizing data for quantitative data next. Now we are going to discuss how to organize quantitative data. Now recall that quantitative data is really numerical data. That's data that's given to us in the form of numbers. And we also discussed that numerical data can be of 2 types. One is called the discrete quantitative data, and then we have continuous quantitative data. All right. So depending on what kind of numerical data we are dealing with, we will have to construct 3 different types of tables. All right. But which one we will be using will be decided by the type of data we are using. All right. Or we are handling in this situation. The one form is called the single value grouping. The other one is the limit grouping, and then we have what's called the cut point grouping. So we will go through the steps of constructing frequency tables for each kind, and also we will discuss when we should be using what kind of grouping under what circumstances. Then the other 3 bullets here, the histograms, the dot plots, and the stem and leaf, are the graphical representation of quantitative data. All right, so there are 3 kinds of graphical representations, and we will discuss again each kind one after the other and show how we construct these different plots. We are now going to learn how to create a frequency table of the type single value grouping. We said previously there are can be three types of frequency tables for quantitative data. We'll first discuss how to create a single value grouping table. So let's look at the example given to us. We have the data set here, and this represents the number of TV sets in each of 50 randomly selected households. So I guess what they did was they inquired in 50 households, asked them how many TVs do you have in the house, and these were the varied responses they received. And if we just eyeball the data, we see that the lowest value is a 0. That means there was one household that did not have any TVs, so they responded 0, and the highest value reported was a 6. So there were in fact two households that had 6 TVs in the house. All right. Now, see over here that the smallest value is a 0 and the highest value is a 6. It does not extend beyond that range of values. All right. So 0 to 6. Now, our when our data set extends over a narrow range of values, or a small range of values, in this case from 0 to 6. That means the total number of unique values here is 7, including 0, right? So when we have a situation like this, then we can use the single value grouping method. All right, we don't have a value which is 20 or 75 or 87 or even higher, right? It's values, a limited number of values extending from 0 to 6. So in that situation, we can use the single value grouping. And what is that? For us, in a single value grouping, in the first column where we list our unique responses, we can give each value a separate row. So we list each unique response in a separate row. So 0 is the first one that it's arranged from in ascending order from lowest to highest. So we start with 0. So 1, 2, 3, 4, 5, 6. All right, so that's our number of TVs. And then we, of course, there was a column where they tallied the data. That means they went through the data one by one. So one, they put a tally, and they didn't show that row because we don't need to unless we are counting the data. So this is it's kind of a summarized table. But this is how, if you recall, how we did the tally for quantitative data. It's the same process. How we did the tally for qualitative data, right? For political affiliations. For quantitative data, it's the same process. You go one by one through your raw data set. So 1, cross it out and tally it. Then the next one is a 3. You have to put a tally for 3. Then the next one is another 3. You have to put another one. Then a 0 gets a tally. The first one was a 1, right? So we have to really tally it here. Then there is another 3. So 3. So that's the process. But they haven't shown that column, but they have instead shown the frequency column, all right, where the total number count. So it's 1. So one person or one household reported 0, so we have 1. Then 16 household reported they had 1 TV, 14 reported 2, 12 reported 3, 3 reported 4, 2 reported 5, and 2 households reported 6, and for a total count of 50. So they queried 50 households. Your frequency must add up. All these frequency values must add up to a 50. It should equal to your total sample size that they used. And that is denoted by the letter N. All right, N equals, and F is denoted by F. So or the frequency is denoted by F. And in the third column, we have to calculate the relative frequency using the formula F over N. And how did we get this values here? 0.02 is 1 divided by 50, right? So it's 1 divided by 50. Then it's 16 divided by 50. F over N, 14 divided by 50. All right. So the numerator value represents your frequency number and the denominator is N. And we get all these relative frequency values. And when you sum up the relative frequency values, it should always equal 1. All right, that's the total number. So what is relative frequency? Conceptually, relative frequency is the proportion of responses of each unique value, of each unique response, really. All right, so that was what single value grouping is about and how to create the single value grouping frequency table. Just keep in mind in single value grouping, if you have a limited set of unique values, as in this case it was 0 through 6 only, you can list your individual responses, the individual values in a separate row. All right. Now we will discuss frequency tables of the type limit grouping. Now, previously we talked about single grouping where we could list each unique response in a separate row. In limit grouping, we cannot do that because we have our data set, which is not of a limited range. All right, it's not of a limited range. And we will go through it, but let's try to understand what this data is about. This data is about the days to maturity for 40 short-term investments, right? So that means they looked at 40 investments, short-term investments, and tried to determine how many days it took for each to mature. All right, so this is the data set, and these numbers represent the number of days to mature for these 40 different short-term investments. So the first one took 70 days to mature, the next one was 62, then 75 days, 57 days, 51 days. And if we look at the values here, eyeball the values, I think the shortest number of days, rather the smallest the investment that matured within the shortest time, shortest number of days is 36, and the highest was probably 99. All right, so the lowest value, the minimum value in our data set is a 36 and the highest value is a 99, but the range of values between 36 and 99 is a lot more than what we had in our single value grouping example. In our single value grouping example, where we asked how many TVs a household had, we had responses extending from 0 to 6, only 7 unique values. Here we have a wider range of values starting from 36 all the way to 99. So if we listed each value in a separate row, then we would have to go 36, 37, 38, 39, 40, everything all the way to 99, and it would be difficult to manage. It would be a long list of values, may even go over to 2 pages, right? So that's why what we do is we group them together in intervals. All right, so over here we see the first column is days to maturity, and what we have is intervals, group intervals, really. All right, so you see here we have 30 to 39, 40 to 49, 50 to 59, 60 to 69, and all these intervals are of an equal width. So we start from 30 and then go to 39, and the next interval starts from 40 to 49, 50 to 59, and if we look at the width of each, so 40 minus 30 is 10, 50 minus 40 is 10, so they are intervals that are 10 numbers wide. 60 to 50 is 10, 60 minus 50, 70 minus 60 is 10. So, all right, they have equal intervals. So that is very important when creating these intervals. Your widths should all be the same. And likewise, on the other side too, 49 to 39 is 10, 59 minus 49 is a 10, 69 to 59 is a 10, 10 all the way. So all your intervals must have the same width. All right, you cannot have 30 to 35 for the first interval and then maybe 36 to 49, which is not the same width. All right, the width of each interval should be the same. That's the rule. And then once we have set the intervals up, and your intervals, all these intervals from the first to the last one, should cover all the values in the data set. So the lowest value was 36. That will fit into the 30 to 39 interval range, and the highest values are 99, which will fit in the 90 to 99 interval. All right. So once we have our interval set up, we will of course use the same method of tallying. We will go one by one through our data set. First is a 70. Where is the interval for 70? This one here, right? This one. So we will put a tally for here. And then the next one is 62. So where is 62? The interval for 62 is here. We put a tally here. Next one is 75. Again, in the interval, we put a tally in the interval for 70 to 79. That's where 75 will fit in. And this way we go through the entire data set, complete our tally, and then in the third column, we count our tallies and write the numbers. So 3, 1 for in the 40s. Then we have 8 in the 50s, in the 50 to 59 range. And then 10 in 60 to 69, and so on. And when you add up your frequencies, make sure they add up to the sample size, which is n, 40. All right, they should all add up to 40. If it doesn't, then you have to go back and check if you've tallied it correctly or not. You may have missed or double counted a value, so just go back and check. This helps to cross check that we have done our tallying and correctly and the counting correctly. And then finally we have the relative frequency f over n. Same formula, same process. Just take your f values, divide by n. So 3 over 40 is 0.075, 1 over 40 is 0.025, and so on. So we have to run the list, and then again your relative frequencies must also add up to a 1. All right, so that's how you work through your limit grouping frequency table. All right, so again, keep in mind that for limit grouping, we use that. First of all, we use a limit grouping for discrete data. So here it says days to maturity. So the number of days, we count days, we don't measure dates. So this is discrete data. All right, number of days. And limit grouping can only be used for discrete data when our unique responses have a wide range, when there is a wide range of values between the lowest and the highest value in the data set. Now, the cut point grouping frequency table has been explained quite well in the textbook that is on Canvas in PDF format. So please read about it from the PDF file on this topic. It should be under the textbook section on the modules. But I'm going to try to explain the cut point grouping using the data we used for the limit grouping, but I'm going to change it a little bit. Now, first of all, the cut point grouping is used for data which is in decimal form. So it's used for continuous quantitative data. That means the data will be in decimal form. All right, so it's used for data in decimal format. Let me write that down. Decimal format. Now, limit grouping, we said previously, is used for discrete quantitative data. So the values that we had in the table for days to maturity of short-term investments were all integer values. All right. Now, for cut point grouping, I'm going to explain cut point grouping, I'm going to modify this a little bit, the values here a little bit, and explain why we cannot use the limit grouping for decimal data. All right, now, so let's remove this here. Instead of calling it days, let's just assume this is some other kind of uh, example, nothing to do with days and all that. And let's say some of this data would be in decimal form. So I'm going to modify a few numbers here. So for 89, I'm going to say it's 89.2. Right, and then let's find another one for 69. Let me use a different color so it doesn't get mixed up with the black. Just a second. So let's say this is 89.2, and then another number is 69.5. Anything else that I can change perhaps? Wasn't there something else? Yeah, this one, let's make that 39.7. I think this should be sufficient. All right. So when we go through the list, and let's say we set up our intervals as limit grouping. All right. So, here for the first number 70, yes, we can find an interval for 70. We would place it here. And then for maybe 64 also we could place it here, not a problem. If we had a number which is, let's make this 55.1. So if we had a decimal value which was 55.1, that would fit in between 50 and 59, correct? And if this was 64.3 perhaps, all right, let's modify a few more values. So 64.3 would find a place in this interval. So we could go like this, correct? However, if we came to 89.2, when we came to 89.2, let's find a place for 89.2 in this limit grouping interval. Where would 89.2 is greater than 89, right? So we couldn't fit it in this 80 to 89 interval. Could it go in the next interval? No. This is 90 to 99, right? So we don't have a place for 89.2. Likewise, 69.5, where would you put it here? It wouldn't be in 60 to 69 interval because this interval stops at 69 and our number is 69.5. It wouldn't go into the 70 to 79 interval either because this 70 is greater than 69.5. Therefore, 69.5 doesn't have a place. 39.7, same thing, right? So, in order to handle these kind of situations, we create our interval like this. We start like this. 30 to 39 is fine, but we make it like this. 30. Let me just write it here. All right, so instead of writing 30 to 39, we can write it as 30 to less than 40, right? And then for the next one, it starts from 40 to less than 50. And then 50 to less than 60. All right. 60 to less than 70 and so on. 70 to less than 80 and 80 to less than 90, and then finally 90 to less than 100. This is one way of writing or creating the intervals to accommodate decimal values, to accommodate continuous quantitative values. See, now we will find a place for a number like 39.7. 39.7, anything less than 40 will go into this interval. 32 less than 40. So 39.7 will fit into the first interval. Correct? How about 89.2? 89.2 would fit into this 80 to less than 90 interval. All right. So there would be a repeat though of these values. So, but we have less than 40. So this interval, the 30 to less than 40 interval, would fit in values as close as possible to 40, but as soon as the number is a 40, we have to move to the next interval. All right, so if the value is 39.99999, we could still place it we could still tally it in this interval. However, as soon as the number becomes a 40, we have to move to the next interval. All right, so that's how the cut point interval grouping is written. So it'll be as less than and so on. You could also write it as 30 to less than 39, and then 39 to less than 49 and so on. Uh, but whatever width you used, again, the width for each interval should be the same. Okay, so that's about the cut point grouping interval, and keep in mind the cut point grouping is used for continuous data. If you're working with discrete data, then which is all integer values, then go with the limit grouping. Let's talk about some terminology now using the limit grouping table that we just created. The first one is the lower class limit. The lower class limit is the smallest value that could go in a class interval, in a particular interval. So in this list of intervals, 30 is the lower class limit. 40, 50, 60, 70, 80, 90. Those are the smallest values that could go in that interval, that would fit in that interval. It's called the lower class limit. The upper class limit, likewise, is the largest value that could go in a class. So in this case, 39 is the highest value that could go in the class. Anything greater than 39 will have to go in the next interval. All right, so 39, 49, 59, 69, 79, 89, 99. These are the upper class limits of this frequency table, the class intervals. All right, and keep in mind that limit intervals, limit point grouping is only for discrete data types, discrete quantitative data types. All right, so that's why you will not see a 39.5 in your data set. This will not accommodate for any decimal values, right? Now, the next one is the class width. The class width is the difference between the lower limit of a class and the lower limit of the next higher class. That means how wide, when we talk about the class width, it means how wide each interval is. And the way to figure it out is take the lower limit of one interval and From it, subtract the lower limit of the previous interval. So 40 minus 30, all right? So if you do 40 minus 30, you will get a value of 10, right? So 10 is the class width in this case, but we have to make sure that all the intervals are of the same class width. So you may want to check that for all intervals. So 50 minus 40, right? 50 minus 40 should be a 10. 60 minus 50 should be a 10. Then 70 minus 60 should be a 10. 80 minus 70 also a 10. And 90 minus 80 also a 10. And you should also check that on the other side. So take the upper class limit of one of the intervals, and from it subtract the upper class limit of the previous interval. It should all be a difference of 10, right? All should be a difference of 10. And that tells us that all the widths are of equal intervals and they have a class width of 10 in this case. All right. Now, the other thing here is the class mark. The class mark is the average of the two class limits of a class. That means it's, in other words, the midpoint of an interval. So we may want to write it like this. It's also the midpoint of the interval, right? And how do we calculate the midpoint? We just find the average of the two class limits. So in other words, take the lower class limit, add the upper class limit to it, and divide by 2. That's the midpoint formula. Lower class plus upper class, let me just write it down. Lower class limit plus upper class limit, which is, and it's a plus, all right, divided by 2. So 30 plus 39 is 69 divided by 2. So 69 divided by 2 would be 34.5. So the midpoint of this interval 30 to 39 is 34.5. That of 40 and 49 is 44.5, 54.5, and so on. All right, so that's how you find the class mark, which is also the midpoint of the interval. Now, we will need this class mark value when we have to find the mean from a frequency table. All right, so we'll do that later on in the next chapter, but the class mark is used to find the mean or the average of the data set using a frequency table, right? So here is a summary of when to use which of these grouping methods. The single value grouping is used for discrete data in which there are only a small number of distinct values. So if the range of values are a limited amount, then we use the single value grouping. Then we can write each value in a separate row on our table and then tally it. For limit grouping, use when the data are expressed as whole numbers, so that means also discrete numbers, and there are too many distinct values to employ single value grouping. So if there are too many distinct values, then if you write each of them in a separate row, then you may run out of the page. It'll flow through the page onto the next page, and then it'll be difficult for us to manage. So that's why we group them into intervals and then place several numbers within that interval, or several values within that interval. The cut point grouping is used when the data are continuous and are expressed with decimals. Let's go into the graphical representation of quantitative data now. The first one is histograms, and The histograms are pretty similar to the bar charts that we had learnt about under qualitative data. However, there are slight differences, but histograms are used for quantitative data, data which comes to us in the form of numbers. So let's go through the steps, and as you will see, the steps are pretty similar uh, to the bar charts, except there are slight differences. So the first step is to obtain a frequency, a relative frequency percent distribution of the data. Now, most often you will be asked to uh, create histograms of relative frequency, all right? So, but sometimes you may also be asked to create one for frequency, but relative frequency is most commonly used and asked for. But so we need to create our table, whether it's a limit grouping or using cut point grouping or single value grouping. We have to have a frequency table, and in that we should calculate our relative frequency as well. And then in the second step, we draw a horizontal axis on which to place the bars and a vertical axis on which to display the frequencies. All right, so that's also very similar to what we had learned for our qualitative data for bar chart. So over here we will have our this time our x-axis will have numbers. All right, we will use numbers because this is all numerical data, and along the y-axis will be our relative frequencies or percentages, whatever we may be creating the histograms for. Step 3, for each class, construct a vertical bar whose heights equal the frequency of that class. All right, and then step 4, label the bars with the classes as explained in definition 2.9, so don't worry about that. The horizontal axis with the name of the variable and the vertical axis with frequency, relative frequency or percent. So we always have to label our axis for the common person to understand what data we are looking at, and also add a title. All right, so on the tests we have points assigned for the title, for the labeling of the x-axis, the y-axis. So make sure, even if you have constructed the histogram correctly, don't forget to give it a title and label your axis, otherwise you have a chance of losing points. All right, so these are the steps. We'll go on to working through an example of this, right? We are going to now work on an example to create the frequency histograms. This one is to create a frequency histogram as well as a relative frequency histogram. And we are going to use the data, the same data we use, that is the number of TVs per household. We use the same data to create a single value grouping frequency table, if you recall a few slides back. All right, so here we have the number of TVs, then the frequency, and then the relative frequency is also calculated. We will need both frequency and relative frequency, as well as number of TVs to create our histograms. Now, the first one here is the frequency histogram, and the second one is the relative frequency histogram, as you can see from the label of the y-axis. All right, now since we have our frequency and relative frequency, the frequency table, we have completed the first step in the series of steps that we just talked about in the previous slide. So we can go to the next step where we draw our horizontal axis and a vertical axis. So along the horizontal axis, we mark our number of TVs, the distinct values in our data set 0 through 6. All right, that's our x-axis, or we show them on the x-axis and make sure that each of these values are equally spaced from each other so it looks nice and neat. All right, and then along the y-axis we mark our frequency values. And the highest value in our frequency was a 16 and the lowest value is a 1. All right, so they have scaled the y-axis starting from 0 and then intervals of 2. So 0, 2, 4, 6 all the way to 16. All right, so you should always try to kind of spread it out so it doesn't get too cramped and it's hard to understand how tall the lines are relative to each other. So this is pretty well spaced and we can easily tell which number occurred more frequently, the highest and then the next highest and so on. Okay, so once we create our axes and label them and mark them, scale them, we have to now plot our uh, rectangles. All right, these are the rectangles. So for 0, the frequency was 1. So where there is a 0, you just draw a small rectangle, go up to, so where is 1? 1 would be somewhere between 0 and 2, right? Somewhere here maybe. So that's how high the rectangle is around 0. Okay, so I'm going to erase this because that's not a part of the histogram, but I just wanted to indicate where 1 would be, and that's how high the rectangular bar would go above 0. And then for 1 it's 16, so look, this one goes all the way up to 16 and then turns, makes a right angle and comes down. All right, and then for 2 it's 14, so you see this rectangular bar goes as high as 14 and then turns around, comes back. For 3 it's for the next one it's 12, right? 3, 12. So it goes this rectangle goes all the way to 12 and so on. I guess by now you understand how this is going to go. All right, all the way to 6, and there are for 5 and 6 it's the same frequency, so these two rectangle bars are the same height. Okay, so that's about the frequencies. Now note one thing, that these bars are all against each other. All right, there's no gap between the rectangular bars, unlike with qualitative data. So when we created a bar chart, there was a gap between uh, each of those. I think we worked with the example of Democrats and Republicans and others, the political affiliation problem, and there was a gap. And I had told you that make sure if you're working on a bar chart for qualitative data, make sure there's a gap, there's a space between each bar. For histograms, there shouldn't be any space. Please don't, because that's an error. All right, you will have points deducted if you put gaps between the bars. For histograms, there are no gaps between the bars. All right, they should touch each other, as in this case. Now for the relative frequency, it's the same thing. The x-axis or the horizontal axis is scaled the same way as with frequency, only that the y-axis, all right, it's scaled with the relative frequency values. What's the smallest value is a 0.02 in our relative frequency, and the highest value is 0.32. So they have scaled the y-axis starting from 0 and then intervals of 0.05 all the way to 0.35. We don't need to go beyond 0.35 because the highest value of our relative frequency is 0.32. So that will cover all our relative frequency values. And then you just go about drawing these rectangular bars. For 0, it's 0.02, so it's somewhere close to, somewhere between 0 and 0.05, slightly less than the midpoint. So this bar shows the relative frequency for 0 number of TVs. All right, and then we have 0.32. So 0.32 goes all the way a little bit above 0.30. And then we have one for 2, 3, and 4. So but this time we're working with the relative frequency column. All right. And then always again make sure you put a title to your histogram, and you label your axis. All right, the horizontal axis, number of TVs, vertical axis, relative frequency, etc. All right, so that's how you create or go about creating frequency and relative frequency histograms. Pretty much the same as bar charts, except that make sure your rectangles touch each other. There's no space between the rectangles. Now, the next graphical representation of quantitative data that we're going to learn about is called the dot plots. Now, as the name suggests, it's going to be a graph with a plot of dots aligned to the different data values that we have. All right, so let's read through it, and then again we'll work through an example. It says here, a dot plot is a graph in which each observation is plotted as a dot at an appropriate place above a horizontal axis. Observations having equal values are stacked vertically. All right, so if this was not easy to understand, let's go through an example and it'll be very clear. All right. Now, before we go to the example though, let's go through the steps to construct a dot plot. The first step says, draw a horizontal axis that displays the possible values of the quantitative data. And then in step 2, record each observation by placing a dot over the appropriate value on the horizontal axis, and finally label the horizontal axis with the name of the variable. So not too many steps, but these steps will need to be repeated. Step 2 rather will need to be repeated, not step 1 really. Now note another thing, that for dot plots we don't need a vertical axis like we did for the histograms, all right, or the bar charts. Here we just need a horizontal axis, and the horizontal axis will be scaled. So we'll just have one horizontal axis, and that horizontal axis will hold the different unique values in our data set. All right, and it should be scaled. The horizontal axis should be scaled at equal intervals for each data value, and then we are going to place dots uh, based on the occurrence of a particular value. All right, so let's go through an example instead of trying to talk on the steps. This is the example we are going to use to create our dot plot. The example is about the price in dollars of 16 DVD players. And here are the prices: $210, $224, $208, and so on. Right now, remember the first step is to draw a horizontal line and scale it such that you have a place for all the values, all the distinct values in this table, all right, in our data set. So our lowest price is $197, and the highest price is what is it, 219, is it, or 224, right? So we have to make sure that we scale our horizontal line such that we can position our 197, the lowest value, as well as the highest value. And again, it has to be scaled at equal intervals. So what they have done is they have started from 190, and then they have created the interval or shown the interval uh, in intervals of 10. So 190, 200, 210, 220, and 230. And they've also shown the scales in between the intervals. All right, so this is 190, 191, 192, 193. This is 195, then 200 and 205, 215, and so on. You get the idea, right? Now, to create the dot plot, what we need to do is we have to go through our data set, data by data number. We have to pick each value and then plot it on this horizontal scale. So just like we were doing our tallying when creating a frequency table, we have to go by each value. So 210 is the first value. So 210 is here, right? 210 is here. So what we do is we put a dot. All right, we put a dot just above 210. All right, the next one is 219. So let's use a different color. 219. So where is 219? 219 would be 1 less than 220. So I'm going to put a dot here. All right. Then we have 214. So 214, let's cross it out. All right, 214. So where is 214 here? It'll be somewhere 200. This 215. Let me show you. This is 215. So 214 will be 1 less. So no, I'm sorry. 214, I'm looking at the wrong section. 215 is here. So 214 will be right here. Correct? So let's say it's here. Then we have 197. Let's cross that out and find where 197 would be located. And 197 would be 3 less than 200. So this is where 197 is. Then we have a 224. So 224, let's cross that out first so that we don't double count. And 224 would be over here. Right. This 220, so count 4 from there, 221, 22, 23, 24. It's right here, so you put another dot here. Now the next one is 219, all right, 219. So 219 would be 1 less than 220. Now, since we already have a dot for 219, you have to place the second 219, the dot for the second 219 just above it. All right, so that's why they have a dot right above. Then we have 199. Cross that out and mark your 199 is 1 less than 200. So if this is 200, 199 would be here. It'll be somewhere here, right? Just right above that point. Then we have another 119. So let's cross that out and put another one dot for the second 119. For the second 119. 208. 208. Let's see, where would that be? 208 is 2 less than 210. So this is 209. So 208 is here. All right. And then 208 is gone. Then next is 209. For 209 will be over here. Okay. Then we have 215. 215 should be 5 intervals above. So this is 215. Then we have 199 again, right? 199, it goes right here. All right, so I guess you are getting the idea how to create your dot plot, and then once it is complete, it tells you the distribution. You can just look at it and understand the distribution. You have 3 values which were 199, correct? And three values which were 219. The highest value was 224, the lowest value. So even if you didn't have this data set, you could just, if you were just given a dot plot, I mean, you needed the data set, of course, to create the dot plot. But if you were just given this dot plot and don't show somebody the uh, data set, they can get all the data points from this dot plot. All right. So, and this tells how the values are distributed. All right. So you see most of the values are around 210. So most of the DVD players cost around $210. All right. So that's how you create dot plots. It's not a very tedious process, but it's a simple process, but it gives a lot of information about the data in pictorial form. Now the final form of graphical representation for quantitative data is called the stem and leaf diagram. This is a rather interesting form of diagram where we split our data values into two, into a stem and a leaf by digits, by their digits, and then represent it as in a tree form, so to speak. And then it gives us pretty valuable information about the distribution of our data. All right. So here it says in a stem and leaf diagram or stem plot, also known as stem plot, each observation is separated into two parts, namely a stem consisting of all but the rightmost digit and a leaf which is the rightmost digit. So what this means is if we have a value, a two-digit value, let's say 87, then we split it into two. All right, the rightmost digit, the extreme most digit is called the leaf, and the digit to the left, or all the digits to the left, is called a stem. All right, we'll go through the process in the next couple of slides, but just want to explain how we divide or split our data values into stem and leaf. So if we had a value instead of 87, if we had 875, then the extreme right most digit, this 5, would be our leaf. All right, it would be our leaf. And this entire digit 87 would be our stem. Everything to the left of the rightmost digit would comprise the stem. All right, and then we will split the two. We split the leaf and the stem, but we have them side by side. But it's a rather interesting way of representing the data. So let's go through an example. But another thing I wanted to say though here is that stem and leaf diagrams only pertain to integer values, I mean discrete quantitative data. All right, it's not usually used for continuous data with decimals in it. Let's check out the steps we need to follow in order to construct a stem and leaf diagram before we start working on an example. Step 1 says think of each observation as a stem consisting of all but the rightmost digit and a leaf the rightmost digit. All right, all but the rightmost digit means everything to the all digits to the left of the rightmost digit. All right, that's what it means. So if we have a number which is 87642, let's take a large number, it's 87,642, then in this for this value The rightmost digit is the 2. All right. And everything to its left will be considered as all but the rightmost digit. All right. All but the rightmost digit. And this rightmost digit is going to be called the leaf, and everything to the left of that leaf, all the value numbers, digits to the left of the leaf will be considered as the stem, right? So whether it is a 2-digit value, 2-digit number, or a 5-digit number, the rightmost digit is always regarded as the leaf, and everything to its left is the stem. Now, step 2 says write the stems from smallest to largest in a vertical column to the left of a vertical rule. So by vertical rule, they mean that you draw a line, all right? You draw a line in between that. They're calling that line a rule. All right. And then what you do is you write the stems from smallest to largest. So let's say uh, we will have several values, not just one value. Like in this case, this is for me to just explain to you which part of the number would be leaf and which part of the number would be stem. So you take all your stems and arrange them in ascending order from lowest to highest on the right hand side, sorry, on the left hand side of this rule. All right, in the vertical column to the left of a vertical rule. So that means, let's say our numbers, just I'm making it up, 47, and then the next higher would be 49, 52, 57, 62, 63, and so on. All right, let's say these were 3-digit values. All right, so what we do is in step 3, this was step 2. What I just did here, writing the numbers on the left hand side of this line, was completing step 2. In step 3, write each leaf to the right of the vertical rule in the row that contains the appropriate stem. So if there was a number which was 472, then you're going to write a 2 on the other side of this line next to that 47. All right. If there was a number, let's say 490, then we are going to write a 0 on the other side of this line, or what they call the vertical rule. All right. And then in step 4, we arrange the leaves in each row in ascending order. So here too, we have to go through our numbers, our data values, one at a time, and write the values of the leaf and then arrange the leaves in order, in ascending order. So let's build a stem and leaf diagram, construct a stem and leaf diagram using this data set given to us, days to maturity for 40 short-term investment. We've seen this data before. We constructed a limit grouping frequency table, and these are all integer values, right? So to draw a stem and leaf diagram, or to create a stem and leaf diagram, remember we have to split our values. Each number has to be split into a leaf and a stem. All right. So the unique values we have, if you look at just the uh, leftmost values, start from the lowest was probably 38 or 37, or no, 36, right? So anyway, the lowest stem value that we will have is a 3, and then there is something in the 40s, maybe. Yes, we have something in the 40s, so 4. Then there is one 5, so 50s, 60s, 70s, 8, and 9, correct? So that's why they have here. All right, this is the vertical rule that we were talking about previously. On the right hand side in blue, we have all the stem values, all the stem values. All right, and then we have to go through this data set one number at a time and note the leaf values. So we have arranged our stem values. These are the stem values. Now we have to write our leaves. So the first one says 70. So what we do is go to where 7 is, the stem of 7, and on the other side of the line, write a 0. All right, so we are writing a 0 here, putting a 0. Then the next value is 64, so go to where 6 is, where the stem for 6 is, and 4 is, well, they are going actually column to column, so let's do that. All right, otherwise I'll end. You can go across also, but since they've already worked it out and I'm overwriting uh, their work, I'll be out of sync. All right, so this is the one we are crossing, and you write your 2 here. Then the next one is 75, so you write a 5 next to the 7. Then we have a 57, write a 7 next to 5. So here, let me just show you with my pointer, 5, 7 goes there, so 7. All right, then we have 51. All right, 51, there's a 1 here. The next one is 64. Where is 6? Here next to the 2 we write a 4. Then we have a 38. Where is 3? That's the first one for 30s, right? So 8. All right, then we have 56. Go and write a 6 next to the 5. All right, so these are all the leaf values, and once we have completed, we've gone through this entire data set and written out all the leaf values, we have to arrange them in ascending order from lowest to highest, and that's what they did here on this side in as part of B. They just arranged, nothing, no calculations or nothing to be done here except just arrange it from lowest to highest. So 6, 8, 9, 4, and then there was only one value in the 40s, so 7. And then 7 we had for 5, we had 71635105. It's now arranged in proper ascending order, 011355567. All right, so this is how you construct your stem and leaf diagram. And again, by looking at the diagram, even if we don't have this data set, by looking at the diagram, you can tell what values are in your data set. So there's a 36, there's a 38, there's a 39, and then there's a 47, 50, 51. There were two 51, so 51, 51, 53, 55, 55, and so on. All right, so you can get your an idea about your not only your data values but also the distribution. So if you draw like a curve here, all right, something like this. All right, this is our curve. And all right, I'm going to erase this. This doesn't look too good. All right, it should be something like this. All right, so the curve should look something like this. But what I want to say is you can look at it and easily see that the data, more of the data values are in the 50s and 60s, right? And then there are some in the 70s, 80s, 70s and 80s. You have equal number of values, and then 9, and the lowest is in the 40s, and so on. So it gives you a lot of idea about the data and their distribution, these stem and leaf diagrams, right? Here's another example of the stem and leaf using a different data set. This data set is records the cholesterol levels for 20 high-level patients. So these are 3-digit values. A cholesterol value above 200 is considered to be high cholesterol level, really. So these values are all 200 and above, except one which is kind of low or just at the borderline. So what they've done is they have split each of these values into the leaf and stem. So keep in mind it's always the rightmost digit which is your leaf. All right, the rightmost digits. Leaf. All right, leaf and leaf, and everything to the all the digits to the left of a leaf would become the stem. All right, so because these are 3-digit values, one, the extreme right becomes the leaf, so the 2 other digits in the 3-digit number become our leaf, and the smallest value is 199. So 19 is a leaf, and then 20 is a leaf. So these are all arranged in ascending order, the stem. However, when we go through the list to record the leaf values, then we have to go, we cannot really arrange in ascending order right away unless your data set is arranged in ascending order to start with. All right, but here again we go one value at a time to record the leaf value. So the first one is 210. You put a 0 next to where 21 is on the other side of the line. Then we have what, 200 and uh, which one do we have? 217. All right, 217. uh, you record a you record a 7 next to it. 208, wherever there's 20, put a 8. Now they've shown here this arrangement in ascending order, so they already went through the process. They didn't show that part here where they went one value at a time to record the leaf, and then they did the arrangement from lowest to highest, and then they presented it to us. What they really want to show here is there's you can extend this, you can take this and do this little bit differently with 2 lines per stem. Instead of writing 119, they wrote 2 19s, 2 20s, 2 21s, 2 22s, and they treat it like this. The first 19 is going to have values from 0 to 4, and the second 19 is for values 5 to 9. All right, and that's going to be the way for all the stems. The first stem is going to be 0 to 4. The next stem is going to be 5 to 9. All right, so that's how the 2 lines per stem work. And what happens is, if you use this this strategy to create the stem and leaf, your distribution is a lot more manageable. Over here we have too many values next to 21. When we did it 1 line per stem, we saw a whole bunch of a long list of values for 21. Sometimes it's difficult to read it. All right, if you have a long list with one. Here, if you create the stem and leaf as 2 lines per stem, it is a lot manageable. So we can see here that we have values 21, 210, 4 values for 210. Then we have a 212, 213, 214, and then 215, 217, and 2 values of 218 come to the next line for 21. All right, so that's just a way of creating the stem and leaf diagram. You can do it either way. However, it's more manageable if you have a long set of data values and you use the 2 lines per stem. It becomes a lot more manageable and also easy to read and interpret.